Okay, so this first part should just rewrite the expression in radical form and simplify. So you can't have any negative exponents. So it's the first thing I'm going to fix. So it's 1 over, what do we want in radical form? Might as well change it to radical form at the same time. So 16 to 5 halves. That would change into 16 to the 5th. And square root. This is 12 over 1. 16, there's basically 5 copies of those. So we would have 16, 16, 16, 16, 16. You got to think of this, we're just taking square roots. So there's 5 square roots of 16. Each of them equals 4. So you end up with 4 times 4 times 4 times 4 times 4. So that's 1024, and that's on the bottom. So that's our answer. Second problem, 27 to the 2/3 would change into 27 squared, and we want to take the cube root. Again, the 2 means there's 2 copies, so I got 27 and 27, and we're going to take the cube root of that. Cube root of 27 is just 3, so we get 3 times 3, so the answer is 9. 8 to the negative 1/3, kind of like number 1, so we flip it first. 8 to the 1/3, that makes it positive for the exponent, and 8 to the 1, and we want the cube root of that. Cube root of 8, that's just 2, so the answer is just 1. Second part, basically the exact same thing, just the opposite. So we're going to change this into exponential form. So we've got negative 64 to the 1/3 power. Now you can kind of see the problem already. It says the cube root of negative 64. Well, if you just work that out, that's negative 4. This one would be 32 to the 3/5 power. And so we've got 3 copies of the 32, and we're doing a 5th root. So the 5th root of 32 is just 2. So 2 to the 3rd ends up being 8. This last one, we've got the negative on the outside. So this is 625 to the 3/4 power. We have the negative on the outside, so I'm going to leave that kind of like this. So the 4th root of 625, I think it's just 5. So we've got 5 to the 3rd power, so that's 125. And then we have the negative on the outside. That's our answer. Next part is just simplifying the expression. So you've got 4. You're going to add 1/5 to negative 3/5, so that's negative 2/5. And then we're going to simplify as much as possible. So this ends up being 1 over 4 to the 2/5. And I think if you work out 1 over 4 to 2/5, that's 16. But you can't take the 5th root of 16, so I think that's just, it just stays there. Number 8, the 3/4 goes to everything, so 256 to the 3/4, x to the 6/4, we reduce to 3 over 2, and then 81 to the 3/4. And when it comes to these numbers, you can just do those in the calculator. So 256 to the 3/4 power ends up being 64. X to the 3 halves. And on the bottom, we have 8 to the 3/4 power. That one actually doesn't work. It's a decimal in the calculator, so we can probably, let's see, well, I guess we can simplify it a little bit, but I'm just actually leave it. So 8 to the 3/4 power. Next problem stands pretty much the same. So 8 to the 1/3, x to the 3, and then y to the 2/3. 8 to the 1/3 means the cube root of 8, so that's just 2. So it's 2x to the 3rd, y to the 2/3. Okay, when we get into these adding and subtracting problems, actually I'm going to jump around a little bit because there's some that are kind of similar. So number 15, 3 times 4 is 12. Then we add the exponents, so we get x to the 3/3, so it's just x to the first. 16 is kind of the same, so negative 2 times 5 is negative 10. X to the 1/4, so you got 1/4 plus 1/2. That ends up giving you x to the 3/4. So that's your answer there. Let's see what else we got. Do some stuff with the radicals. Let's see, not the adding, subtracting, and multiplying, but just the regular simplifying. So the index is 5. That means you need to see how many times you can go into the exponent. So for the x, you can go in once, so you don't have to put the 1 there. For the y, it can go in once, but we're also going to have 1 left. And then for the z, it's going to go in twice. And then we'll have 2 left there. So the leftovers, we're going to have the 5. We're going to have 1 y, 2 z's. Number 12. Number 12, we're doing a square root. So square root of 81 is 9. 2 goes into 16 8 times. 2 goes into 2 once. And then 2 goes into 20 10 times. So there's your answer. And that one doesn't have any leftovers, so that's just the final answer. Okay, now for the, so we have some adding stuff here. So if we're going to add, they have to match. So we're going to break this down. This is 27 times 2. And that cube root, well, I guess I can just break this down. That's 3 times 3 times 3. So the first one is going to give me 3 cube root of 2. And then 128, you can always divide that by 2. So 128 is 2 times 64. And 64 is just 4 times 4 times 4. So that means we can take out 4. We got the cube root of 2. And so now since these cube roots match, we have the same cube root of 2. We can actually combine like terms, and this is negative 1 cube root of 2. Let's see, so now we've got our multiply. So to multiply a radical with a radical, you multiply the stuff inside. So that's square root of 20. Then we have plus 2 square root of 10. We multiply these, that's negative 3 square root of 10. Multiply these, and that's, I gotta multiply the outside with the outside. So negative 3 times 2 is negative 6. And then we have a square root of 5 left over there. The 20, looks like 20 can probably break down. So 20 breaks down into 5 times 4, which is 2 times 2. So that means we can take out a pair of 2's. We'll be left with a 5. We can combine these guys. That's actually it's a negative. So minus 1 radical 10, minus 6 radical 5, and then 2 minus 6 is negative 4, radical 5, minus 1 radical 10. That's your final answer. Number 14 is done the same exact way. So 1 times 2 is just 2. 1 times negative radical 5 is negative radical 5. We multiply these together. 2 times 2 is 4 radical 5. And then 2 times negative radical 5 is negative 2 radical 5. So we end up with a bunch of, I guess, like terms in this one. Negative 1, yeah. Okay, so all 3 of these can go together. So it's negative 1 plus 4 is 3. 3 take away 2 is 1, so it's positive 1 radical 5. We have the 2 in front. That's our answer. And that looks like that's the entire page.